Let's solve Leetcode 704 binary search. It's an easy question. Problem is given an array of integers, numbers, which is sorted in ascending order, and an integer target. Write a function to search target in numbers. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with big O of log n runtime complexity. So example 1, given numbers, we're also given target, and we're asked to find target 9 in numbers. And if we scan numbers, we will find the target at index 4, 0, 1, 2, 3, 4. Okay, example 2, we're given numbers and we're given target 2. We don't find 2 anywhere in the numbers, so we return -1. 2 does not exist. Okay, so we're required to write implement binary search. This is classic binary search problem. So binary search works by repeatedly breaking down or splitting the array into 2 and searching on this part of the array that will potentially contain the target or the value we're looking for. Okay, so let's quickly do that. We're going to use pointers left, right, and midpoint, and we're going to compare with our target. So we do int left starting at 0, which is the left boundary of the array, and right, which will be the end of the array. So we do numbers dot length -1 because we're dealing with indexes. Okay, so when we use a loop and continuously choose either left or right part of the array. So we do while left is less than or equal to right. Equal to because we need to also search when both pointers meet each other. So we need a midpoint in between the boundaries. So we can do that by using integer division, but I'm gonna do something else to avoid integer overflow. So I'm gonna do left plus in brackets right minus left divided by 2. So this will avoid integer overflow for really large numbers. Okay, so now the comparison. If numbers in midpoint, if the number at this index equals target, then we found it. We immediately return mid. That's our index. Okay, now there's another case where this number could be bigger or smaller. Okay, let's do bigger first. So if this number we have at this index is bigger, that's greater than our target, then we should search the left side of the array. So to do that, we do right equal to mid -1. So we just shorten the array and move to the left side of the array. Now, the last case is when that number at that index is less than the target. We need to search on the right part of the array. Now, to do that, I could just do else, and it will take care of that case. So I could say else left is equal to mid plus 1. That should take care of that case. Okay, so what we've done is compare, and if we find it, then at an index, we return the mid, which is the index we're looking for. If it's bigger than the target, we search on the left part by saying right equal to mid by -1. And then the last case is when it's less, smaller, when the number we have at that index is smaller than the target. So we need to move on to the right side of the array by doing left equal to mid plus 1. If the loop finish, if execution jumps out of this loop, we never found the target, this condition was never met, then we need to return -1, which is what we're told from the instruction to do. Okay, so this is the solution for binary search. It's a big O of log n because it does half of the job each time by splitting the array into 2. So let's go ahead and run this problem and make sure 2 test cases pass. Now let's go ahead and submit it, and then all the test cases should also pass. Okay, good. It was submitted. I hope this helped. That's it for this video. Please be sure to like and subscribe to my channel. Thank you for watching.